Hi, I'm Lee Taylor Penn, and I'm a first-year public health student, and I'm also a coordinator for the Sustainable Food Systems Initiative. And I have the pleasure of introducing one of the interdisciplinary faculty with the Sustainable Food Systems Initiative. It's Regina Baucom, and she's an assistant professor in ecology and evolutionary biology. Her favorite food is a tie between chocolate and coffee. And she will be speaking on herbicide resistance and weedy plants, current status, and future prospects. Please welcome Gina.
Hello. Okay, can everyone hear me? Okay, so I'm Gina. I'm in the Ecology and Evolutionary Biology department here at UM, and I'm going to tell you about what I know about herbicide resistance at this point. So what I'm showing you here is a soy field in North Carolina. This field, you're probably very familiar with a view like this. It's a monoculture crop of soy. The soy has dried down and it's about ready to be harvested with a farmer's combine. A farmer would be very happy about the way that this field looks because it's relatively weed-free, okay? They can get their combine in, they can harvest their soy, and everyone's happy. Well, most everyone. So this, alternatively, is another soy field that's about ready to be harvested. Just a picture that I took down the road in North Carolina. This field is also, you can see the soy is the dried bean there, but this field is infested with the common morning glory. So this is one of the more noxious crop weeds that exist down in the southern part of the states. So this sort of infestation leads to a problem in that the farmer can't get their combine in, and it leads to lower yields and decreased quality of the soy. Okay, so the weed infestations have a huge economic cost to the agricultural economy. They can lead to between 12 to 34% in crop reduction per year. This can translate to about 33 billion lost to our agricultural economy. In addition to that, another 4 billion is spent per year in the use of herbicides. Okay, so this is, if you believe these numbers from David Pimentel, this is $37 billion per year of our agricultural economy going to reduce the effect of weedy plants. Okay, that's a huge amount of money. We didn't always, however, used to use herbicides as the major means of control of weedy plants. Hand weeding was replaced by herbicides after World War II and the increased use of pesticides. So you can see here, we've got the increase in agricultural chemicals right here after World War II and the decrease in farm laborers. So what happened after one of the industrial revolutions is farm workers went from the farms and into the factories, into cities, and farmers at the same time started to use chemical means of pest control. So interestingly, even though we've shifted our methods of use of removing weeds from agricultural systems, the yield loss of crops has maintained since the 1960s. So we're still losing about 12 to 30% of our crops per year. Even though the mechanization has changed between mechanical means of reducing weeds to chemical means, we're still having the same amount of yield loss. One of the reasons for this is herbicide resistance. Okay, so weedy plants have evolved mechanisms to allow themselves to persist in the face of being sprayed with these chemicals that are designed to kill them. Okay, and so as a result of increased use of chemicals to remove weeds from crops, we have this increase in herbicide resistance over time. So you can see from the 70s on to now, we have many different herbicide-resistant biotypes of weeds globally as well as in the U.S. So in the U.S., we've got about 160 biotypes. That's just different types of the same species of weed that are resistant to herbicide. What this translates to in terms of species is about 70 species of weeds in the U.S. are resistant to the different types of herbicide. Okay? So what's my stake in the game? What am I studying? I'm not a weed scientist necessarily. I'm an evolutionary biologist and I study adaptation to the agricultural system. So how do weeds develop defense to herbicides, these chemicals that are designed specifically to kill them? We think about this in multiple different ways in the lab. So we think about the level of defense in nature in terms of within population processes. So what's the level of selection from the herbicide on the plant population? What are the relative benefits versus the costs? How has resistance been introduced to the population? Is it through a single gene mutation? Is it through gene flow from outside sources? And what's the impact of the mating system? So plants can both outcross and they can self. How does the plant mating system influence the evolution of herbicide resistance? And we answer these questions, we think about these questions using the common morning glory. So this is an Ipomea species, and you're probably pretty familiar with this. You often see it growing up mailboxes and, of course, on crop rows. Okay, so just more broadly, what's the current status of herbicide resistance in terms of farms? What are farmers dealing with? Right now, they're at a standoff, okay? So they've transitioned a lot of their crops to Roundup Ready crops, and as a result of that, many different species of weed have evolved herbicide or Roundup resistance. Okay, so right now what they're doing is they're using previous herbicides that they were using back in the early 90s in addition to their use of Roundup Ready technology. And they're moving back to mechanical control. So they're going into their crops and removing, say, the really noxious horseweed by hand with a machete. So what are our future prospects? Is that really right? We've only elapsed 1 minute? No, okay. I'm like, that can't be right. I practiced this. Okay, okay, good. So our future prospects on the short term, we're starting to use stacked varieties. What this means is that we're developing GMO technologies that have 2,4-D resistance or dicamba resistance, as well as glyphosate resistance, okay? So a crop species will have multiple mechanisms of resistance to different classes of herbicide, and that allows the farmer to use different rotations of herbicide. Some people are mining the soil metagenome for bio-herbicide properties, and this one woman, Ann Kennedy, this is an interesting story. She has identified 2 different strains of Pseudomonas out of 25,000 that are specific to killing cheatgrass. And cheatgrass is one of the worst weeds out in the western part of the country. It's specific to cheatgrass. It doesn't kill any other weeds or any other plants. We're also using drones and robots. For example, this particular robot has been designed to find a weed and pound it into non-existence. Which it's interesting and we laugh, but it's really thinking about removal of weeds a couple steps away from a human influence, right? So it's not the farmer going out and finding their weeds, it's a drone going out and finding the weeds. In addition, we're developing allelopathic crops. So these are crops that have chemicals exuded by their roots that make weeds really poor competitors. And in addition to that, just continued hand weeding. So there's a picture here of people hand weeding organic onions. So that's it.